Hi students, in this video I'll be going through the 2023 O-Level A Math Paper 1 question 11. Right, so this is a question related to applications of differentiation, more specifically rates of change. Okay, so let's read the question. So a circular patch of water of negligible thickness is expanding on a thin piece of paper. So at time t seconds, the rate of change of the radius RCM of the patch is given by this equation. dr dt equals to k over 2t plus 1 cm per second. Okay, where k is a constant. Okay, so basically we know that when we drip, let's say we drip some water on the paper, right? Okay, so the water is going to spread out due to capillary action. Okay, so in this case, we assume that the patch of water is a ideal circle. Okay, it's the shape of a circle, and then as time goes by, the circle gets bigger and bigger. Okay, the water will spread out. Okay, so when the circle gets bigger and bigger, then the radius of a circle will increase lah. Okay, so let's say this is the initial radius of the water droplet. Okay, so it's going to get bigger and bigger. So the radius will increase as the size of the circle increases. Okay, so as illustrated in this diagram on the right side. Okay, so the rate of change of the radius is given by this equation, dr dt. Okay, so because the radius is getting bigger and bigger, so there's a rate of change of the radius with respect to time. Okay, so it's given by the equation k dr dt equals to k over 2t plus 1 cm per second. All right. Okay, so they want us in part A to show that k is 0.5, so they give us some info over here in this slide. So initially the radius of the patch is 1 cm. So they are saying initially means what? Okay, if you recall, initially means when the time of this particular experiment, right, is 0. Okay, or this particular scenario is 0 seconds. Okay, so initially the radius of the patch is 1 cm, and the radius is increasing at a rate of 0.5 cm per second. So radius is increasing at rate means dr dt. Okay, the radius is increasing is 0.5 cm per second when the time is equals to 0. Okay, so we can actually make use of this piece of info to help us to find the value of k. Okay, so what we can write is when t is equals to 0, dr dt is equals to 0.5, right? So we can formulate an equation and then we can use it to find the value of k, right? So k over, okay, so remember now t is 0, so we will replace the t with 0 plus 1 will be equals to 0.5, right? So k over 1 equals to 0.5. Okay, so this means that k is equals to 0.5. Okay, so we have successfully shown that k is 0.5 already. All right. Okay, so let's move on to the second part of the question. So part B, they want us to find an expression for r in terms of t, right? So since we know that k is 0.5 already, we have already found it. So we can write dr dt as this, right? So 0.5 over 2t plus 1. Okay, so this is the expression for dr dt already. Okay, so find an expression for r in terms of t. Okay, so if you want to find an expression for r and we know the equation for dr dt already, so what we need to do is we need to integrate dr dt with respect to t. Okay, then that will allow us to find r. Okay, so basically what we're going to do is we're going to integrate dr dt with respect to t. Okay, and that will allow us to find the value of r. Okay, so that's basically what we need to do. Okay, so we're going to integrate this. Okay, so integrate dr dt with respect to t. Okay, and this will, the left side is going to become just r. Okay, so if you recall how to integrate this 0.5 over 2t plus 1. So basically what you can do is you can bring the 0.5 out. Okay, so you get 1 over 2t plus 1 then dt. Okay, then when you integrate 1 over 2t plus 1, it's going to become ln of 2t plus 1. Okay, then basically what you need to do is differentiate the inside. So when you differentiate inside, you will get 2, right? Okay, so will divide the 2 below. Okay, then because this is an indefinite integral, so there's going to be a plus c behind. All right. Okay, so we're going to simplify this a bit first before we try to find the value of c. Okay, so 0.5 divided by 2 is going to be 1/4. Okay, so it's going to be 1/4 ln 2t plus 1 plus c. Okay, so 0.5 over 2 is 0.25, which is 1/4. Okay, so how are we going to find c? Okay, this value of c. So to find this value of c, what we need to do is we need to look at this particular expression. Initially, the radius of the patch is 1 cm. Okay, so the radius of the patch is 1 cm. Okay, so if the initial radius of patch is 1 cm, means when t is 0, r is equals to 1. Okay, when t is 0, r is equals to 1. Okay, so we need to make use of this piece of info to help us to find c. All right. So that's basically what we are going to do now. So when t is equals to 0, r is equals to 1. Okay, so we're going to form the equation. Okay, so r is 1 when t is 0, so we are going to get this. C, all right? Okay, so ln 2 times 0 plus 1 will give us ln 1 plus c, all right? Okay, so ln 1 is going to be equals to 0 if you recall. So 1 is equals to, so since ln 1 is 0, so 1/4 times 0 is going to be 0. So in this case, c is going to be equals to 1. Okay, so once we find c, we can rewrite out the whole expression for r already. Okay, so therefore, r is going to be equals to 1/4 ln 2t plus 1 plus 1. Okay, so this will be the answer for part B of the question. All right. Okay, so there's another part to the question. Okay, so let's go and read it. Okay, and this is the part that we will need to use this thing called the connected equation. Okay, so hence find the rate of increase of the area. So find the rate of increase of the area means they want us to find dA dt. Okay, it means what is the rate at which the area is increasing. So remember, this is a scenario whereby the water droplet is increasing in size. Okay, the circular water droplet is increasing in size. Okay, so as it increases in size, the area is going to increase. So they want us to find the rate at which this area is increasing. All right. Okay, so over here, increase in area. Okay, so find dA dt. Okay, so this thing is missing again. Okay, so find dA dt after the patch has been expanding for 3 seconds. So that means when time is equals to 3 seconds. Okay, so whenever you come across a question like this, so remember the first thing we need to do is we need to write out the connected equation. Okay, connected equation. Okay, so usually my approach to this kind of question is I will write whatever I need to find on the left side of the connected equation. Okay, so then the next thing you need to ask yourself is so far what kind of info do we have? So remember we have the r dt. Okay, so I'm going to use the r dt inside the connected equation. So the r dt. Okay, then you need to ask yourself one question. Okay, what will you multiply to the r dt to get the a dt? All right. So since we need a dA on top, so it becomes quite obvious that we will need a dA. Okay, and because we want dA dt eventually, so what we will need to do is we will need to multiply dr dt with dA dr. Okay, dA dr. So you can see that the dr will cancel off, and then you will get the dA dt. Right? Okay, so that's what we will need to do. Okay, so dr dt is what we already have. Then what we need to find is the dA dr. Okay, in order to complete the connected equation. So our aim now will be to find dA dr. Okay, so how are we going to find dA dr? So don't forget that now the water droplet is a circle. So if it's a circle, then what we can say is that A is going to be equals to pi r square, right? The equation of the area of a circle. Okay, so what we can do is we can differentiate A with respect to R, and that will allow us to find dA dr. Okay, so that we're going to do that. Okay, so it's very easy to differentiate pi r square. So we just bring the 2 down and then reduce the power by 1. So dA dr is 2 pi r. Okay, so we're going to insert this inside the connected equation. So 2 pi r. Okay, then dr dt. Okay, don't forget that we have already found it earlier on already. Dr dt is over here. Okay, 0.5 over 2t plus 1. So we're going to insert it inside. So 0.5 over 2t plus 1. Okay, so over here we have this r. Okay, which is remember they want us to find dA dt when t equals to 3, right? So we need to try to replace this r with an expression in terms of t. Okay, so that later on we can sub the t equal to 3 inside and find the dA dt. Okay, so don't forget that in part B we have also found r in terms of t already, right? So it's 1/4 over here. So it's 1/4 ln 2t plus 1 plus 1. So 2 pi, okay, times 1/4 ln, okay, 2t plus 1 plus 1, right? So we're going to insert this thing inside. 1 times 0.5 over 2t plus 1. Okay, so at this point, I think what we can do is we can already insert the t equals to 3 inside. So when t equals to 3, okay, dA dt, which is what we want to find, the rate of change of the area, 2 pi 1/4 ln 2 times 3 plus 1 plus 1 times 0.5, 2 times 3 plus 1. Alright. Okay, then we can just calculate this whole thing out. So 1/4, so ln 2 times 3 plus 1 is ln 7 plus 1 times 0.5 over 7. Right? So you can actually just use your calculator. Okay, so use your calculator to just compute this whole thing, and then you can just give your answer in 368. Okay, so in 368, the answer that I got was 0.667 cm square per second. So now we are dealing with dA dt, rate of change of area. So the unit for area is cm square. That's why we have cm square per second, right? Okay, so this is how you deal with rates of change question.